Hey everyone, I thought it would be fun to do a video about a game that I've made called ArduRacer FX. So I've been working on this game for a while. A couple years ago, I made a game called ArduRacer. It was very fun. I had a lot of fun making it. And with the release of the ArduboyFx, I saw the opportunity to make a lot of updates to the game, and I was quite keen to share that with you. If you can bear with that music. I'm gonna lower it down there. Possibly switch it off. It sounds better on the actual hardware. I like to think. But that's our first new feature that we have. There's music in the game. Unfortunately, I'm not a great musician, but that is very exciting. I had a lot of fun making the intro animation for the game, and let's hop into it. So, firstly, something that I can share. The game used to run at 30 FPS or almost thereabouts. It now runs at 60 FPS, and I've actually locked it to 60 FPS. Currently on the screen, it's using under half the processor, and let's start our game. So here I am on level 1. This looks pretty similar to what the game used to look like, but if I go into the game now, you're going to see the zoom in is a lot smoother than it used to be. This is running at 60 FPS as well. Our zoom starts, and we now have a map in the bottom corner, and the objective of the game is get around the lap as fast as you can. I might switch off sound so I can hear myself better in a second. But you do 5 laps, and your aim is to get around as fast as you can, and your fastest lap will be the time that you measured against. 2 more laps to go. In the top left, you can see the lap number I'm on, followed by the time of the current lap, and how many checkpoints I've passed. Out of the 4 checkpoints on this, I've gone through 1, 2, 3, 4. There we go. I'm on to my last lap. And then just below that, you can see the B, 10.27. That's the best time that I've ever got on the stage. And there we go. Finished the stage. I also missed explaining. There's a speedometer in the top right, and you can see here that I got 10.27 seconds as my best time. The best time I've ever recorded is 8.68. That is here. This is a challenge to anyone who plays the game. If you can beat this time, you beat the dev using all shortcuts and whatever means necessary. The second time is, I'll get to it later, default car, and the third time is something that I hope will be fun to play to, but if you want that extra challenge, beat the dev. That's me. I will happily hear from you what time you got and see if I can beat it. Next up, if we hit our left button on the screen, we can see the 5 lap times that we got, 10.51, 11.93 to 11.23. So you can see I was pretty consistent, but not beating any of my best times. I hit A, I can go to the next, and B, I can go back. So let's do one more stage. But first, I'll turn off sound effects. You can also turn off the map as well from the screen. Continue will take you to the last stage you've passed. Start will always put you on stage 1, but you can scroll up or down to the stage. And then the trophy screen is the only other big feature. You can see here I've got stage numbers on top, 1 through 10. Surprise, surprise, we have 10 more stages in ArduRacerFx. So it's all the way up to 20. And then GSB is gold, silver, bronze. As long as you have the bronze, you will be proceeding to the next stage. You get 1 point for bronze, 3 points for silver, and 5 points for gold. So 20 times 5 is 100 is the maximum score you can get for the 20 stages in the game. And yeah, if you can do that, I will be well impressed. Just want to minimize one of my windows. I was going to do some comparisons just now. Okay, so now that we know about trophies, we know about music, sound effects, the map, there's an about screen here with a picture of me. And if we continue onwards, yeah, we just got our logo, FX, you know you're on the FX version. And let's go to another stage. So here I am, level 2. And if you press left on the level select screen, you now get a tuning menu. So by default, you have 4 points on everything. And you can take away points by going left and add points by going right. You can actually store more than what is possible. And so you can allocate your points wherever you want. If you need to set it back, just press reset or put them all back where they were. If you're willing to sacrifice a little bit of acceleration for speed, you can do that. If you want to take some turning off, you can do that, even it out. So I've taken 1 point from acceleration, 1 point from turning, and given myself a top speed increase. The difference, it's about 10% per dot on here, so you can take off up to 40% from that default, and then you can add an additional 30 up to 30%. So kind of choose your poison. Where do you want to give up something to get more somewhere else? And then when you're done, you can press save, and that will take us back to this screen. The config that you save for the car, that's going to be for all your stages from that point on. So if I go back to stage 1, I go into tuning, it's the same setup that I've already got. Go back to stage 2, same setup. So you can modify your setup for your car, and then that will be applied to all stages. So that is just a caveat with the setup of that. And so let's go. Let's do second stage. Got our zoom in. We've got the countdown. I've turned off the sound, but you get your beep, 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 and then we're off to the races. So you can see on the map, the white is for things that are considered road, and then anything black, dark will be for anything that would be considered off-road normally. And it's just to give you an idea. On the later stages, which are bigger than 10 by 10 tiles, it will show a partial map which will scroll along with you driving. Let's see. You can see I'm going a bit faster now, and I'm not hitting my turns as well. So maybe I could go back and tune again. And the blinking dot on the map is where you are as well. So you can see on this map, there's no scrolling. The whole stage fits in the mini map, and my little blinking dot just makes its way around as we go. Here we go, 10.76, not too far off. So, okay, since I didn't explain it properly the first time, I now have a tuned car, and that would be trying to beat first place. That is hell or high water. Tune the car how you want, find the shortcuts on the circuit, do whatever you can, beat my time. Time 2 is exactly the same, but with a default car. So if I go back to default, all of those second place times are set with the default car. Same criteria, however you can, make it to the finish line, get your best time. Cool. So comparisons, that's actually very fun to do for me. So kind of the whole way through the setup, I'm going to switch to a different screen. So here you go, you can see more of my screen, and we can see over here, we're running at 36.6 FPS on the screen. If I go back, you see 60 FPS here. So the promise wasn't in the menus. This is actually, let's get into the game and do the level. So you can see here, it's locking pretty close to 60 FPS. I can maybe make that bigger. But now as the game kicks in, we're locked at 60 FPS. We're using 70% of the CPU. So there's actually a lot of headroom for nothing really. I mean, this is pretty much the extent of what the game will use. It needs to work out your speed, your direction, and it only ever needs to draw the tiles on the screen, so those don't really, it doesn't really affect performance as we get to bigger stages either. So the bigger stages, this is considered 10 by 10 tiles, it's the default. I went up to 16 by 16 initially, which fits into a 256 character array. And then after that, I was quite keen to see how far I could push it. And I did 30 by 30, but I got pretty tired of building maps at the point where they took that long to do. So 10.27, you can see I'm throwing up pretty consistent times to match what I've set as my best. I'm not concentrating fully, but it just gives you an idea. Yeah, I do set these times. And also, I only did it on hardware. So when I played the game, I played through every stage on hardware, getting those times, and then I took those times, put them back into the game. Then I tried to beat them again, and that carried on like that quite many times. Yeah, so that's pretty much an intro to the game, a bit about how to play. One of the other interesting features is that now A is accelerate and B is also accelerate. I love that. In the 3 years that the original game was out, I had never once used brake to set a best time. So I thought, why even bother having it? I was wanting to switch accelerate from the A button to the B button, and actually the easiest way to do that would have been to have a menu that would swap, and you could swap your accelerate and brake, but I didn't have any space on that menu. So I've already got the music, the sound effects, and the map. So what I did, made sense to me, hopefully makes sense to you. If people are dying to have brake back in there, it's not a big issue. You can grab the source code and hack that in. Cool, so on this webpage, get up Tony M128 ArduRacerFx, and there will be a new post in the Arduboy community pages. There is everything you need to know about the game, a lot of what I've talked about, and more things that I'm going to go through in a minute. So anyone wondering why the FX chip, why are you using the 16 gig ROM, and what are you storing on there, and how does it help the game perform? So number one, I've put all the assets are now in the FX chip. So it's just really gameplay code that sits in the hex file that is the compiled binary for the game. And that allowed me to do a lot more things. So I was running at 99%, I think it was, of the space. I was using compressed assets for almost everything. And this allowed me to move the assets off, move to using uncompressed assets so that they could load onto the screen quicker and therefore speed a lot of the things up. So the tile rendering is actually where I gained a lot of advantage by moving to the FX chip, and to show that, here is the old version. It's not excessively different from a first glance. I've tweaked a couple things, but for the most part it's very similar until you get to a point where it's not. So let's, in ArduRacerFx, we're going to come into our screen, and pretty much a similar setup. You can see I've optimized some of the tile layouts. If we go in here, there we go. Optimize some of the tile maps. I've also got it's a different font now. It's a bit smaller. It fits the Arduboy better, but maybe on full screen, this one might be considered nicer. nonetheless, let's move forwards. You can see the times have changed. During development, I found that going from 20 FPS to 60 FPS affected a lot of the gameplay. And so when I found a time that I was happy with, or rather settings for the speeds that I was happy with, I thought it would be safer to lock the FPS and make sure that I didn't break that. So yeah, without further ado, let's give the original a run for its money. And you can see here, we 60 FPS into the game, and then we drop down to 30 and back up. Oh, I started the wrong game. While we're playing, we can press up. Okay. And that will pause. So there's more controls for you now. While we're playing, we can press up. If you press down from this screen, it will take you back to the level select screen. Okay. Comparisons are made. So you can see here, the zoom's going pretty slow. It's a better zoom, and I'll explain how that was done. But we're only getting 20 FPS in the game, and yeah, this is chunky. So all of the images that's showing on the screen are compressed into the 40K that you have for your game, 60K you have for your game, and that causes a lot of slowdown with the rendering. It was still fun. I was very happy with this game when I made it. It's just the comparison now that strikes me a bit. One of the other advantages of the smaller font, it takes up less space on your screen. So you'll see here, paused is not exactly taking up the entire screen. And there you can see the map is integrated as well on this version. So with the smaller fonts in the corner, you've got more ability to see what you're doing on the screen. And on the res of the ArduBoy, you're not really missing much detail in the font. Okay. So if we continue here, we'll finish our lap. Oh, so one of the other cool things with the additional space that I have, you'll see that this has 8 animation points. So there's 1 for going left and right and up and down, and then there's 1 for each of the diagonals as well, which was really cute and cool at the time, and I was very happy with having this many animations. But now, with the FX chip, I've actually added in extra animations in between. So there's now a lot more like turning distinction. You can see here as the car goes around, where you get a much better of an idea of the direction we're facing in. So previously it was 45 degrees per frame, and now it's like 22.5 degrees per frame that determines the direction you're facing in. Okay. Another thing to mention, this is now using the FX Save feature. So your saves are going onto the FX chip, not into EEPROM. So any games that are using the EEPROM saves have less chance of collision or overriding this game saves. This will all live in its own save file on the FX chip. And that's handled by the FX libraries. Okay. Sorry, there's just me, competitive streak. I want to finish all my levels. So there's my times for the stage. Was it good enough? Yes, it was 10 point. Oh. Next. Cool. So you will notice the first 10 stages are actually the same as ArduRacer. And that was very specifically, I made one tweak to stage 10, but other than that, the stages are exactly the same. The tweak to stage 10 had been, well, level 10 had been sitting with me for a couple of years. With the bigger maps, there was also an issue that I needed to be able to allow you more time. I think my best time on one of the later maps is in the 80s or low 90 seconds. So that is quite a big deal. That kind of covers a lot of the features that we have in the game. And yes. So that kind of covers the new FX features, comparison between the new and the old game. And now I'd like to go into some technical details that I really enjoyed about this. So let's zoom in a little bit more. You can see the 10 stages, 3 times to beat, 30 FPS gameplay, track view, speedometer, and dynamic zoom into the level. Now we've got all of that. Additionally, 60 FPS, 20 stages. If there's a drive for it, I could add another 10 stages potentially. Stages 18, 19, and 20 were meant to be fun and try do something to the extent of the game engine, maybe even breaking it a bit. So try have fun with that. Don't take it too seriously. Yeah, just meant to be great fun for everyone. The integrated map. That is quite possibly going from one of the easier features I want to one of the biggest features I wanted. So the map is very cool. It was something I always wanted. All these games have always had it that you see. And I went and added it in, and suddenly my frame rate tanked on the 10 by 10 tile maps, the first ones. It was actually fine. But then we went to the bigger stages, and suddenly my frame rate wasn't hitting 60 FPS anymore. And then I went to the even bigger and also struggled with that. So we finally hit the point where we're diving into code, which may be the cue for the people who just want to play the game to jump off. But thank you for watching this far for anyone who did, and thank you for watching further if you do. Okay, cool. So the map was an issue. The dynamic zoom would not work, so I wanted to bring the zoom in. The way that I'm doing the assets now, I used to use ArduBitmap the whole way through this process. And so ArduBitmap, it's a cool library. It has a ability to compress images, and you load them from ProgMem, and this way you could have way more assets in your game. Like, I would have never been able to include as many levels as I did in ArduRacer and as many tiles as I did without this. So this was a cool library, and I only got to release my game because of it. But as I was moving to the FX, this didn't support the FX, so I actually did hack it to support the FX. And then I had some issues trying to get it to load uncompressed images, so I hacked it some more, and I took out all the images from here and started using the FX libraries. But if you have a game that you'd like to transfer to the FX and you know how to use ArduBitmap, this took the simplest approach to getting it working on here. So if you search through the ArduBitmap file, you will see eventually code that I haven't commented out. Over here, we're requesting from the compressed bitmap, which is, instead of sending in the array, I send back in the uint24 that the FX data uses for its assets, and this is one of the compressed assets that I've copied over. So instead of specifying it as a progmem array, you specify it as a uint or character progmem array. You do a uint at, and you can pop it straight in here, and you're good to go. And so whenever it uses this, it has to request data from the FX, and people will tell you much better ways to do this, but my naive approach, and it worked for me, was just to read exactly what I wanted out of the FX, and I don't worry about anything else. I wanted this byte, I got this byte. I wanted that byte, I got that byte. And wherever I want to read from the FX, wherever I would have previously read from the array, I read out of the FX using this. So yeah, it was actually relatively straightforward changes. A good library from, good code from ArduBitmap that was easy to transfer over, and then the FX library that actually also made it really easy to use. So that is ArduBitmap. Maybe about a bit of nostalgia for my original game. I was actually okay with not removing this. It costs me a bit of space. And actually at this point, the only thing I'm using it for is the drawing the numbers. So that is the exact same code, but now the assets are stored on the FX chip compared to, between ArduRacer and ArduRacerFx. Which was quite nice because this zoomer took me a while to get right. So the only addition in here is it now plays the sound properly, the beep, 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 and then it should play the beep, but it actually gets overridden by your car roaring sound down the track. So that is the zoomer. This was a segue from the map. So the map that we are showing on the screen, I will get to it. What was happening is I was making so many calls to the FX to build up the map every frame that it started tanking the frame rate. And so I had an idea to build a level cache, and the level cache is to store the smallest amount of data that I can to know about the levels. And if we go look at this, where it's defined and used, find it. Map display. Okay, so if we go look at the map display, the map display is a Boolean array, so it's one bit that we're storing to say whether it's a piece of track that you can drive on or not drive on. And then it's a square, so 10 by 10 tiles is the size of the cache I'm using, which happens to fit the first 10 stages. And then for the later stages, it won't fit those. So if we go look where we're using this, we check whether our cache is valid or not by knowing a couple stats about where the player is and what tile they're on and whether it's changed. And then we will update the cache if we need to. And do we update the cache? We do. Oh, there. Okay, so if these numbers change, then yes, we would repopulate the cache. Where is that cap? And then instead of finding out, oh, I see. No, sorry. This is build the map cache. That's why I was so confused. So this is building the map cache if your player's X tile or Y tile has changed, so they've moved, then we build the cache again. But only if that is necessary. Where does the map cache start? Starts at 0, 0. Should the map cache be at 1, 1 now, and then cover that part of the map instead of that part of the map, or any other part. So is the cache the same starting top left point? Yes, that's how I did that bit. And then I'll redo that for you if you need. And then we have my super complex drawing code. This is the drawing code for the map. We find out well, we check whether we have to build the cache or not. We find out the level tile we're on, the map Y, and then we run through drawing all the tiles every time onto the screen. And it's double-sized, so the tiles take up twice as much space as they need to. We can get back in here quick. So this is actually 4 pixels. It's 2 across, 2 down, 4 pixels that are showing there. It gives it a nicer size on the screen, makes it easier to identify what you need to. And then afterwards, we just draw our player on the top at their coordinates, which we work out. And we just decide whether we're flicking it. It flickers every 200 milliseconds, I think it is. So 5 times a second, it will change color. And then the same thing, we're drawing to the 4 pixels. And then the speedometer. Speedometer's been updated along with the issues. So it shows for the map size, which is the level cache size, if it's bigger than what we can store in the cache. And so that just means that that bar is the same size as the map is wide. And then your percentage here, so even if your car is faster or slower, the bar is the full speed for your car. So you know you've hit full speed when you get to the top. I had enabled LEDs, and I did not like that. It was blaring in my face with every frame. I was trying to get, like, you know, the intensity ramped as your speed went up, or colors changing. If you go off-road, that would have an impact. But I didn't find anything else comfortable leaving on, so I disabled it over here. Next up. So the much smoother zoom, intro zoom animations, I really love this. Let's switch back to the game view. If you haven't seen it enough, I will show you one more time. So this animation here is what I'm talking about. And this is running at a solid 60 FPS. It's got a bit of headroom for more speed. And away we go. Zoom. Okay. So that zoom animation, before I showed you, I was using ArduBitmap, and it was a dynamic zoom. Using the single image, it would scale it down to the size that it needed to be, and that would determine from, if I wanted to give you a 3-second zoom, then at 1 second you're this size over here, and at 3 seconds you're that size over there. So that needs to slowly go up, and so you can work out the zoom ratio between 0 and 1. And then slowly have it expand to the size that you wanted, just with some simple maths, and then ArduBitmap took care of the rest. The FX library punches the image onto the screen, and it does it really quickly, which is awesome, but it wouldn't have enabled that effect for me. So I came up with a more old school implementation. If we go look at the assets for the game, which is quite cool, I'll show this just now as well. I came up with the idea of using map tiles. So the map tiles for the game are 64 by 64 pixels. Probably a bit big, but it worked really well compression wise on the earlier version. Also, when you only have to put 10 tiles down to make a map, it's quite cool. So all the maps are made up of these tiles. And this is done using tiled. And so that's a map you'll see later in the game. Spoilers! But if I come back to the first map, this is actually the first map. and you can see we've got our start over here, got checkpoint over there, and then we come around the back, diagonally up the back, and then straight down and back to the start again. And all of these pieces will be there. If you want to mess with the maps, they are in the repo under levels, and you can see all the levels here. The Excel is kind of what I used for exporting, well, it's actually a CSV, I'm pretty sure, exporting into the game. I'll open this up in Sublime. You'll see here that it's just tile IDs, updates everywhere. 20 was not a good example. Oh, Sublime, don't do that to me. So we can see level 1 is a good example because you're seeing it on the screen at the moment. It's also only 10 by 10. And so tile 21 is this one here. And then you'll see halfway down we changed to a different tile. That should be reflected in this. Okay, didn't mess with the track. Did mess with some of the things on the track. Okay. Next up. So you can see some of the other stages. Spoiler. If you're ever looking for tweaks or want to know where you could optimize something or think you might have found a shortcut, this would be a good repository to come to. If you want to make your own maps and make your own game, this would be a good place to start. After another segue. So that is the 64 by 64 maps, and then you'll see on the start screen, I also needed the ability to have this screen, so quite early on I came up with the idea of the smaller tile map. And so we can come into images here. Nope, assets. And I believe I used a 6x6 tile map when I needed. So on the original version, it was doing a resize using the full size images, and the screen did really chunk along. But now in this version, without having the ability to resize, I actually just grab an asset straight off the FX that is the exact size that I want. And when I was looking to replace the zoom, I was thinking, what is another way I could do this? And MIP maps are a thing in old games, so I went that route. I decided to do a MIP map for every 8 pixels. So you'll see here, there's 6x6, 8x8, 16, 16, 24, 32, 40, 48, 56, and 64. However, that wouldn't get you this zoom, which is a bit chunky, but it's smooth, so I'll take smooth and chunky over just chunky. And there's obviously gaps in this, so we want like a smooth transition of a zoom, and we can't zoom in or resize any of these images. And so actually one of the nice benefits of the tile mapping is I just draw the tiles for the size I want. So say if I've got the full map size and I want to zoom from this 6x6 map, I know that the tile is going to go from 6 pixels, I want it to go to 7 to 8 to 9 to 10, 11, 12, get to 16 eventually, say, and then carry on until I get to 64. And so I know the tiles are going to get bigger by 1 pixel every time. And so what I do is up until the point where I'm going to hit the size of a tile. So at 6x6, I've got the 6x6 tile. When I want to do 7x7, I need a bigger tile, but I don't need 8x8 yet. And so what you do is you draw so that everything gets overdrawn. And so I take the 8x8 tile and I draw it right here, and that goes 8 pixels. 8x8. And then instead of going 8 pixels on for the 8x8 tile, I actually come back one and I do 7 pixels, and then I overdraw that one bit. And then when I reach the end of the first row, instead of going down 8 pixels, I go down the 7 I wanted and use the 8x8 tile. And so at 8x8, I'm using the full size of the tile. I go to 9x9, and at the 9x9, I use the 16 tile, so it's actually going to be drawing 16 pixels, but then I only move 9 pixels and I draw the next tile. And it's not perfect, but I mean, for this on an ArduBoy, I'm really happy with this zoom. Like, it's not using a lot of processing resources. It's putting, you know, in the case of this level, 10 by 10, it's putting 100 tiles onto the screen for the first few frames, and then it carries on after that just fine as well. So yes, very, very pleased with my cheese on that one. The features. Let's pause this. So that's the tile zooming. The car animation is better now, as I mentioned. So we can open this up. This is the original asset. And this is the new asset. So this was pretty interesting. We have a bit to unpack here. So in the original version, I had a 8x8 tile map. Oh, sorry, 10 by 10. And you'll see that everything fits in here really tight. And so when you actually want to rotate this further, this bit would pop out and that bit would pop out. Or for the 10 by 10 box that you have. And so I actually made it a 16 by 16 box. And you'll see that the tiles now moved, has white space around it, and then the car has now quite possibly moved out of the 10 by 10 box that it was in. And so that enabled me to add all the extra directions in. I think I had looked at doing this in the original version, but then having to expand the size of it was prohibitive to me doing that. There is a font implementation in the FX library that I didn't know about. So I actually made my own font, which I got. So I've got the font sheet here. Another thing I hadn't realized the last time I'd made my own font was actually that most fonts that you receive on a bitmap like this, you grab the characters you want from the tile position, and all of these are actually in their character code position. So the maths for doing that isn't actually that hard. Why are you starting up again? Let's pause that. So here, the printing routine, you can see that I am grabbing the font from the FX, and I'm just drawing the bitmap from the position, line X, line Y, and the font for the font ID. Draw normal. Where is... Oh, okay, and the font's a fixed size, so it knows how to, so this, draw it out of the bitmap. Why do I feel like this isn't... Oh, okay, cool. This is one of the FX features. So if I go to the definition of this, which will actually be in FX data, font. So when you do the underscore 4 by 6, it knows that this is actually a tile map and it's 4 wide, 6 high, and so you'll be able to grab things out of there using an index, and the index is the font ID that I want. And so I've actually just got a define that takes the character out of the string, and minuses 32 from it, and then everything actually fits in. So sorry, it's not an exact mapping, it's just off by 32. And so that's a really simple way to go from a string, a character, to the tile map itself. So yeah, initially I was struggling a bit with space. I was using my own font, and this was just a easy-ish way of getting around that. So here you'll see the layout of my FX file. Like I mentioned, all the assets are actually in here now. Even copied over the strings. So I have two print methods. The one is for printing text still. So the text you see, dynamic text you see in game. Okay, problem with the emulator. The first time I save a new build, it always has an issue. But after that, it saves fine. There we go. So get into a level, and all the text you see in the top left over here, that's dynamic text. And so this still uses the string to print, but then everywhere else, I will pull the string. Let's see, FX string paused. So here I've got another print method that will take the string location in the FX data, and then it goes and gets the characters until the end of the characters, and we'll draw the character to the screen. I like one line of white space underneath, and so is one line of white space here that I want from completely blocked off. So it just does that under each character as it goes. FX file, so yeah, you can see the stages in the FX. It pulls those out as necessary. Potentially I could have built a cache for these, but it wasn't necessary to get the frame rate I needed. It would have taken up extra code space. And 920, you can see the last stages actually take up a substantial amount of space. So 10 by 10 is only like 100 integers, but then moving up to 30 by 30, it's 900. So that's a substantial amount. I only got this later on. I used to have like a switch statement that would get the correct level according to the number that you passed in, but actually just building the array is way easier. Here's where all the times are stored for the game. So, you know, whenever I set a new base lap, I can come in and change that here. There's the font. Here's all the assets. There are actually two cars. I don't believe I used this one. Oops. And the tiles go all the way down to 2 by 2. So for the 30 by 30 map, I need the 2 by 2 tile. For the 16 by 16, 4, and 10 by 10, I think uses 6 or 8. And then for all these tiles are for the zoom. I promise they're quite small. All my assets are 50k altogether. It's not taking up too much of the gigabytes you have. To switch, yeah, that's fine. To switch between the tiles, like I say the pixel size, and then it'll nominate the correct tile sheet to use when I'm doing the zoom. Here is the sounds, the music for the game. I'll need to work out a better flow for this the next time I do it. But it actually was a lot of fun the way that I did do it. There's a cool tool. I'll go into tools I used in a moment. Coders Toolbox. Yeah, there it is. So this Coders Toolbox it's a Arduboy game that you can actually use to generate music. I'll pull this out quick. So I can load this in here. Thank you, press play on tape. And you can place your notes down. And then you can come back and edit them if you want. You can stretch them out. And you can add empty space as well. You can go back and edit. What you're looking at is potentially another song for my game. So let's play. And then you can save it to the EEPROM, which is great. There, okay, it did work, which I've never used. And you can export to serial. And the cool thing about Arderns, which is the next tool that I'll need to talk about, is let's view the serial monitor, and over here you can see that it's punched out const and theme progmem. So the only difference you really need to do pulling this into the code is just change it to uint16t fx whatever you want to call it, an array, and then pass in the array. There's probably a way around this, but since the fx tone's end isn't defined, I just worked out what the number was for it and then copied that over. And I'm using ArduTones FX to play this. So tones from FX using ArduboyTones FX. Another interesting change that I made, and it takes me into another tool. When I was originally developing this game, I had it as cross-platform. I could compile it to Windows, Linux, SDL, web browser. There was the Arduboy version, the ESP32 version. And this is an Arduboy game. So one of the things I did is I stripped out, once I started using Arderns, I didn't feel this need to compile for Windows anymore. And so I actually stripped out all the code related to the cross-platform. So in this code base, you won't find any other platform except the Arduino. And a lot of the code has started being fixed towards that in other places as well. But I didn't go through the process of actually getting rid of the cross mechanism that I used. So for the Arduino, if I wanted the Arduino build, when you're making it, you can detect the Arduino platform, and that would cause it to build out the Arduino platform, and it would do that by including the Arduino code base. So you'll see in here, there's a whole bunch of functions defined. I had to define these for all of the platforms, and that's why you'll see primitives like draw pixel, draw vline, draw hline. These were the sort of the primitives that I implemented on all the platforms. Take your input and do your output, and then all the other code outside of this cross had to be generic and only rely on these things. So I mean, the most complicated functionality I put in was drawing a bitmap tile. But say I was running on Windows, I would have the setup for Windows, I'd have the start of the game loop, the end of the game loop, how to know how much time has passed, because certain systems report it differently, and that is cool. So I don't need that anymore, but actually I left it in nonetheless. Another interesting one, you'll see this perf render. When I was having the performance issues, I was trying to look for a way to see or profile where I was spending all my time. And so initially I did profile the render and the update. I thought there would be something in the update that was spending a lot of time. But I saw the update process was using very little. And so I put a perf render in. There's a chance it still works. So even using Arderns, I can do the perf render, and I'll use my build file. So the build file is using Arduino CLI. I moved to this quite late in development. I was using the Arduino IDE a lot. Close this. Pause this, and that's better. Okay, cool. So actually, I do want to be running this. And there's my favorite. Every time I rebuild the data file, I get a new save, and there's some issue with saving the first time around. But after that, it runs fine, and it runs fine in the web player for Arderns, and it runs fine on the actual device. So let's see here. I'll bring up the serial again. So we'll get the serial monitor on the side. And now when I go to play, this code is on the gameplay part only. So when I get the first gameplay frame, hey, did I save my change? Oh, there's probably two of these. There. So you'll see in here I've defined each of these pieces. So a couple variables I need, the function to make sure I have the correct milliseconds, and then working out the splits between all the different calls. So let's try this one more time. Nothing like coming back to code that you haven't used in a while. Okay. So it used to spit out everything down the side here, and then I'd be able to tell exactly how much time each of these had used. Potentially I need debug mode too. Why define it once when you can define it twice? Get milliseconds is no longer around. What's the point in a define if I'm not getting it to propagate? Always need to see if you actually managed to build your app. sorry, just being quite hacky. Might as well just be deleting the comments at this, the if defs at this point to get that to work, but nothing like live demos. And there we go. Oh, yay. Okay. And let's start the game. So we're getting our full frame render times. We can see them here. It should match what we're seeing over here for the most part. So go around for a bit, hit full speed, and pause. Copy, clear. Pause. Actually, I want to pause it while it's in gameplay. So we get an idea of where our time's going. Hey, hey. Okay. Possibly an overload of output, but let's see. So we're going to see before draw, we get the 0. And we can see we have a total of 15 milliseconds. No man, this is really disappointing. I'm spending a third of my render time on the speedometer. Why is that? So between map and speedometer, it literally just draws a couple lines on the screen. Yeah, I've always suspected this was pretty expensive, but it is fine. I can live with it. So yeah, I mean, when you've got the performance you want, you don't go looking too hard, but drawing the speedometer could use some optimization. I mean, it's a third of my render time. So when I was sitting on like 35 or 40 milliseconds, all of it was actually in the map time. So, I'm using 4 milliseconds to actually draw the entire stage. And then car and strings, 2 milliseconds. The map is 2. And the speedometer 5. Wow, I could get that 100 frames a second pretty easy if I took that off. Okay. Anyway, so I mean, the fact that I can get to this sort of debugging relatively easily kind of negates the need for a lot of Windows tooling. I mean, it would be nice to have flame graphs and stuff to have this displayed, but this is more than good enough. Allowing the timing up to 99 seconds was kind of interesting because I encountered an issue with it. Let's get our code base back to where we were. There we go. So the reason I struggled a bit with this is in the FX data, we can go into our save, the save files at the end. The UN24T, 32T, I was not able to get those to work properly in the save data. And actually I was running a bit of a messy bit of code there, and the reason for that is save data. You'll see that I've got the 16-bit times here, but anywhere where I'm doing lap timing, you'll notice it's a 32-bit. And the reason for that is whenever we use the timer, so lap times, the milliseconds being reported by the system, so t frame time milliseconds, where are we defining that? And let's see where we set. So this gets set per frame. It just gets done once to avoid the millis call too many times. And that lets me know come on, where do I set it? So I have the last frame time and I've got the current frame time, and if I work out the diff between those, I know how many milliseconds it took me to get the frame. And then I can use that throughout. It kind of works out as a way of being able to work out how many pixels you should have traveled, or how far you should have gone, how much you should have accelerated if you were pressing down the accelerate button at the start. So you can use that in a lot of different places. I can show an example of that. Get frame milliseconds. And then we're using it throughout the update code. So for instance, my maximum turning speed should be times by the amount of milliseconds that the frame took. So if the frame took longer, I should be able to have turned more during that time. If the frame was quicker, then I should have turned less during that time. So it's just a way of trying to have variables that don't rely on you being locked in at 60 FPS or something. And for the most part, it did work quite well for me. Over here, you can see where we're going up to 99 seconds. And so 16-bit integer, or unsigned 16-bit integer, is like 65536, something like that. So 60 seconds was the most I could do storing the number like this. But actually this whole thing is wasteful, but I'm trying to use the frame milliseconds that I'm getting as I get them. I don't want to lose the precision that I've got with them, to be able to time into like 5 millisecond frames. But I don't need that level of precision when I have the final frame time. And so I just store it as is over here, but then whenever I compare it against the saved lap times, it will be divided by 10 to take away that last digit, and then you'll see it makes a bit of sense with my times over here. It will be 8.68 seconds, 10.14, 1800. And if I was, this easily fits into a 16-bit int, but it would need a 32 if I still had that extra 0 on the end for anything over 65 seconds. Okay, back to the notes. Car tuning. Car tuning was super interesting. I had a lot of fun implementing that, and it actually only took like about an evening. Car tune should be somewhere in here. Bum, bum, bum. So the idea is like you're going to set up a whole bunch of variables for your game, and then the tuning mod is allowing you to sort of take pieces of that away and put it somewhere else. So I defined some fixed variables that defined what that base point was, and that base point for me is that fourth middle column, which is the default. So before tuning, before I had tuning in the game, this is what the car was like. But now you can take away up to 4 points from any of these, and you can add up to 3. And so if you take away 1 point, you'll lose 10% of whatever that was. And that's defined by the mod. So you'll see default max turn speed, that's going to be that middle value, 0.003. And then anything you do will modify it by this amount. So we have default max speed, default acceleration, default mod turn, default max turn speed, default max speed, and default acceleration, and then we modify it by these amounts for every point you go up or down. It's a relatively simple calculation, but whenever you modify the points, I do that calculation. And then your off-roading speed is a third of whatever your max speed is. So the faster your car can go, the faster it will be going off-road, but a third of what it would do on the road. So it's quite cool. Like at one point I even had these variables modifiable in the game, pressing up or down or something. It was really nice for tuning, but actually I locked it in relatively early on because I wanted to be able to set my best times. Even though I was still doing development, I didn't want to change the gameplay. So that allowed me to still work on menus and code and zooms and optimizations, but I actually had fixed stats for everything around that. So FX saving is cool. All you need is, as I showed earlier, to set up the save section in your FX data, and this needs to map the object that you're going to save. This is how you define an array in here, which is pretty simple and straightforward. You need to know how many items you're going to store in it. Like this is a fixed size object. And then inside your code, not saved data, save data. So I've set up this object. It very closely mimics what you see in the FX data, actually exactly mimics. And then we've got all the variables that we're setting. And then you'll see the call is just to pass in the save data, which I've actually just got as a global variable inside of the racer. And whenever I want to save it, I just call the save method, which is a pass through to just save game state. And this takes the entire object and I'll punch it out to the FX data. Loading, also like instantiate the object and just load it in there and return it. So yeah, that is saving. It's so cool that this gets rid of a problem that was a headache for everyone for a long time on the ArduBoy. Super cool. System requirements. So this has to have a ArduFx to play. It's got its own repo app for it. I would have loved to have made a lot of these features work on the original game, but like with the size pressure, I wasn't able to get that in. I did realize 2 optimizations that I made that made a big difference near the end of my dev. I only changed to ArduBoy 2 base right at the end. I didn't need print. Apparently that's quite like a big space sucker, because I've got my own print functions. So once I went to base, that saved me like 4 or 5% of the memory space for code. And then the last one, which is a bit of a sorry Kevin, instead of calling .begin, I think it's start, so ArduBoy dot ArduBoy.boot. So I call ArduBoy.boot instead of begin, which means that I don't show the ArduBoy logo at startup, and that got me in like another 3%, and that kind of enabled me just to actually start doing dev again. If we take a look at what my build looks like now, we're at 93% used, and if I go back to just the stock ArduBoy 2, probably be like 98%, I think. 99, and then if I go back to, instead of boot, we call begin, I'm probably actually going to bust out at this point. And so what happens when you use up all your program space, you can no longer compile, and you've no longer got anything that you can actually deploy to ArduBoy, which is really sad. So let's go back to base and see the difference that makes. %. And up again. %. I mean, yeah, I don't think everyone wants the ArduBoy logo every time they start my game. And I do want the space, so I'm gonna leave it like that. Cool. I think I've covered a lot of what I wanted to. And if there's any other aspects of the code you find interesting and want me to explain more, you can give me a shout. Just closing down Windows so I can get a view on anything else. This repo is available on my GitHub at TonyM128 ArduRacerFx. There will be a community post for this on the ArduBoy community, and I'll add a post specifically for the game release. The cart builder that I've been using is this one. It's really cool. The original version's in here. I'm not sure what the call will be to remove the original version or to add this alongside it. I think it'll be interesting either way. Aww. Nostalgia, it's a thing. If you haven't checked out this, it's really cool. It allows you to build the full cart. There's the one called the whole enchilada, and it's got everything in it. You can do your own custom ones. There is the web flasher that very recently started getting talked about. I had a slightly terrifying moment where I thought I might have bricked my ArduBoy, so I've got to read some manuals before I try that again. But this binary file with the Python utilities has been working really well for me. And I think that is a good point to call it. Awesome. Thank you for watching this far, if you did. And I hope you have a ton of fun playing this game. If it's anything as much fun as I had making it, that is super exciting. See you on the next game. Cheers all.